a continuous random variable has probability density function defined by f of t to be equals to k squared over 3 exponential negative kt t greater than 0, 0 elsewhere. Then you'll be told to determine A, you'll be told to determine value of K. B, you'll be told to determine the mean. C, you'll be told to determine the variance. D, you'll be told to determine the median. E, you'll be told to determine the interquartile range. So you'll be told a continuous random variable has the probability density function f of t to be k squared over 3 exponential negative kt for t greater than 0 or 0 elsewhere, isn't it? Then you'll be told to determine the value of k, the mean, the variance, the median, and the interquartile range. So if you're looking for the value of the constant, that is, you are getting the probability over the whole range, isn't it? So the probability over the whole range gives you a whole range of probability measure, which is what? Which is 1. So you know the probability of x between A to B, then you are integrating from A to B. In this case, it is not x, we have what? T. Of t being between the interval A to B of f of t dt, we are supposed to get a whole range of probability measure, which is 1, isn't it? And then you will know t is greater than 0. Meaning if t is greater than 0, they are telling you A starts from 0 and the end will be what? Senior. Are we together? So what do we have to substitute? From 0 we are integrating from 0 up to the end, meaning from 0 to infinity, isn't it? From 0 to infinity of f of t dt. Substitute the value of f of t on the spot. So, what is the definition from 0 to infinity? The definition of f of t is this, isn't it? It is k squared over 3 exponential negative kt dt. And the answer is supposed to be what? It is supposed to be equals to 1, the whole range of a probability measure. So from here, you factorize out the constant, isn't it? If you factorize out the constant, what do we have? K squared over 3, then we are integrating from 0 to infinity of negative kt dt. And the answer is what? Are we together? Now, if you integrate an exponential function, it remains the way it is, then you divide by the constant of the inner function, meaning the derivative of the inner function must be a constant, isn't it? Because we'll have algebraic substitution. So you can see the inner function here is negative kt. The inner function of this exponential is negative kt, isn't it? And our variable is t here. So it means negative k is a constant. If you differentiate ct to get 1, see the derivative of the inner function will just be that negative k. Are we together? So it means when you are integrating an exponential function, here we have k squared over 3 outside. Exponential function, it remains the way it is, exponential negative kt, then you divide by that derivative of the inner function, which is negative k, which must be a constant. Are you seeing that? Are we together? That was because of algebraic substitution. The exponential function remains the way it is, then you divide by that constant of the inner function. The derivative of the inner function must be a constant. If it is not a constant, then it is something else, isn't it? Are we together? Good. Then you put your limits is from 0 to infinity, isn't it? So factorize out negative k. You will have k squared, negative k is in the denominator. So it is negative k times 3 is what is in the denominator, isn't it? So you get negative k, isn't it? So what will you remain with there? K, negative k over over 3 into exponential negative kt from 0 to infinity. Remember, this k cancels with 1k, yeah, isn't it? You remain with k over 3. Then when you check negative outside, you have negative k over 3. So you simplify. This k cancels with 1k, you remain with k over 3. Then negative coming out, negative k over 3. So if you put in the limits, then the whole of this is equal to what? 1. Now can you put the limits? When you substitute infinity here, what do you get? What do you get? This is what you do. Remember, k is a constant, meaning k can be any known number, isn't it? Then we have negative a constant. So infinity is a very big number. Are you seeing that? So here you have exponential negative. K we know is any known value. Any known value are really behind, isn't it? So it's like we have exponential negative 9. Then if you put the value of g, infinity, if you put infinity, you put any big number, any 9. If you press this in the calculator, what is the answer? Are you seeing how to evaluate infinity in the calculator? Are we together? Remember, negative k is a constant because k can be anything, isn't it? Are we together? K can be any known value. So you choose any known value to represent k. Are you seeing that? So that we have negative 9 or negative 2 or negative 3, it doesn't matter. Then where there is t, we are going to put infinity. So when you are putting infinity in the calculator, you choose a very big number. It doesn't matter whether it's 1 billion or 1 million or 1 million or 9 million, it doesn't matter. What matters is a very big value. The calculator will always give you the answer. What do you get to be the answer if you substitute that? What is the calculator giving you for negative exponential negative 9. What do you get? So here we have negative k over 3. Then when we substitute the upper limit, we get 0. If you put exponential raised to negative, a very big number, whichever big, however big it is, because infinity is a big number, however big it is, you will get what? It will give you 0, isn't it? Because infinity is any big number, however big it is, isn't it? So you choose a very big number to represent infinity. Then when you put infinity there, meaning you are going to get the negative of that big number, isn't it? But if you just take infinity and you don't put the negative here, then you are getting around thing, isn't it? Are we together? Because you can see it was the negative of that big number, isn't it? Is that okay? You substitute that, you get 0. Yeah, that's the best way. I don't want to introduce the issue of a limit here. Maybe limit as b tends to infinity, then we evaluate from 0 to b. We don't go into those details, okay? Then from there, when it is what? 0 for the lower limit, isn't it? If you put 0 here, see 0 will take everything to 0. So exponential raised to power 0 is what? Is what? Anything raised to power 0 is what? Says 1. Yes, if you put 0 where it is, you get exponential 0, isn't it? Because 0 times everything will go to 0. So exponential 0, anything raised to power 0 is 1. And the whole of that answer was equal to what? So here, what do you have? 0 minus 1 is negative 1. So negative 1 times negative, which is outside here, so you get positive. So this you have k over 3 to be equals to 1, isn't it? So what is k? You multiply both sides by 3 to get the value of k, isn't it? So we found the value of k to be 3. So having found the value of k, anywhere you see k, you put 3. 3 squared is what? 9. 9 divided by 3? 3. So it means there we are going to remain with 3 exponential negative 3t. So we now have our PDF, our probability density function. We can now use it to get anything, isn't it? Are we together? So what is the next thing they want there? The mean, isn't it? So what did we say is the mean? The expected value of t, because here our variable is t, isn't it? So the expected value of t gives us the mean, meaning we are integrating t f of t times f of t, isn't it? Are we together? With respect to the variable, with respect to t. Then you put the limits. Where are our limits? From 0 onwards, meaning from 0 to infinity, isn't it? Are we together? So substitute the value of f of t. So you have from 0 to infinity, then t, f of t is 3 exponential negative 3t. So 3 is a constant, you factorize outside, then exponential negative 3t d. Are we together? So you multiply t and f of t to get the mean of t, isn't it? Are we together? Is that okay? Yes, t times 3 exponential negative 3t, we factorize 3 is a constant outside the integral. A constant is factorized outside, isn't it? Is that okay? Good. Now, if you want to make it easier, you don't even need to factorize this constant outside. You can leave that constant inside there. We'll still make it easier. Are we together? You don't have to waste your time factorizing the constant outside. When you factorize constant outside, it means you'll be multiplying everything with the constant which was outside, isn't it? But when you leave the constant inside, meaning the constant is already in the integral, it's already inside it, isn't it? So you don't waste your time multiplying everything with whatever is outside, because there's now nothing outside, isn't it? Are we together? Now, how do we integrate that? Integration by parts, because it is a product of two functions, isn't it? It is a product of 3t. If you look at 3t, 3t is a polynomial, isn't it? And this one is an exponential function. So it is this times this, meaning it is a product of two functions. So we use the product rule, isn't it? And the product rule says what? Then the integral of u dv, you get u, isn't it? Then minus the integral of u interchange. Now it is now going to be vdu. That is the integration by parts, isn't it? When you have a product of two functions. So it means this 3t, the polynomial becomes u. Then the whole of that remaining part becomes dv. So we have u dv. Are you seeing that? Are we together? So start. What is u? U you said is 3t, isn't it? So if you differentiate u with respect to t, you get what? If you differentiate 3t, you get 3. Then taking dt the other side, you get du is what? 3d, 3dt. Are we together? So we have u and du. Then we have there dv, meaning u help us get du because there's du on the other side. Are you seeing? Then dv will help us get v because v is on the other side. Are you seeing? Are we together? So dv you found is what? Exponential minus 3td. The whole of the remaining part is dv, isn't it? Now, if you have dv, how do you get v? You have to remove d, isn't it? So you have to remove d to remain with v. So if you remove d, d is a total derivative, isn't it? So to remove it means we introduce integral on both sides, isn't it? So if you introduce integral on both sides, integral goes with d, with v, isn't it? Are we together? When there's nothing in front here, we treat as a total derivative, isn't it? Is that okay? So you remain with the v is the integral of exponential negative 3t, isn't it? Here, exponential is alone, isn't it? So it's like we are integrating an exponential function. If you want to integrate an exponential function, of course, you already see the derivative of the other function is a constant. If you differentiate negative 3t, you get negative 3, isn't it? So it means for you to integrate exponential function, it remains the way it is, then you divide by that constant of the other function, and that constant is negative 3. Remember when we were differentiating, we were multiplying by the derivative of the other function, isn't it? But when we are now integrating, we are dividing with. See there? Are we together there? So we now have everything. We now go back. Our udv substitute. It is what? The integral of udv was this. It was 3t exponential minus 3td dt to be equal to what? uv. Remember, I'm going to place my limits. My limits are still there. You are going to put the limits at the end to avoid confusion, okay? So it is uv, multiply that. U is times v. This times this. I can see this 3 will go with this 3, isn't it? So t times negative is negative t times that, isn't it? You get negative t exponential negative 3, isn't it? Then it is minus integral of v times du, isn't it? What is v? This times this, isn't it? See, du is 3 dt. Then v is exponential negative 3 over negative 3, isn't it? will cancel with this 3, then dt times negative is negative dt times this, isn't it? So we have negative exponential negative 3td. See, that is what you have. V times du, and you can see V is here, exponential negative 3t over negative 3. Then it is times du, and du is there, is 3 dt. So this 3 goes to that 3, remains with the negative exponential negative 3t dt. So that is how it is. So after that, you can see negative into negative is what? Is positive. So it means we are integrating that part. You have to ensure all the integral you've eliminated on the other side is when you've done with the integration, isn't it? See, this one is now no longer integration by parts. This is exponential alone, isn't it? Are we together? So what are we going to have there? The integral of 3t exponential negative 3t dt is going to be negative t exponential negative 3t. If we integrate an exponential function, it remains the way it is. Remember here, there's no longer product with this exponential alone, isn't it? If you integrate exponential, it remains the way it is, exponential negative 3t, then you divide by that constant. That derivative within a function, which was a constant, isn't it? Are we together? See, like that, you reach the end of the integration. So at the end of integration, we add the arbitrary integration constant. So in this case, we don't add it because we have what? We have the limits from 0 to infinity. It means, therefore, at this level, you now put your limits because you reach the end. You now put your. Are you seeing that? Meaning, inside, in between here, we are still not interested in the limit. And the end is where we now put the limits which we had because we have the limits for all of that, isn't it? Good. Now, start. Remember, the whole of this first term will go to 0. You know why? It will go to 0 because if you substitute infinity here at the upper limit, it will be exponential negative infinity. And the exponential negative for very big numbers, you will get 0. And if you substitute 0 here, see 0 will come to t here 0. See 0 times everything will be 0. See, it's like you have 0 minus 0. Are you seeing? Remember, when you substitute infinity here will be infinity times this one raised to negative infinity. But exponential negative infinity is 0. So 0 times everything, the whole of this will be 0 for upper limit, isn't it? Then again, if you go to lower limit 0, if you put 0 here, where you put 0 where t is, will be 0 again. Are you seeing? Are we together? Meaning when this t is 0, everything goes to 0. And when this t is infinity, this everything again goes to 0. Are you seeing? Are we together? Because the exponential negative infinity is 0. So 0 times this is still 0, isn't it? And t, when it is 0, 0 times this is still 0. So it means that part you are saying that one goes to 0 on the spot. So that is what you are left with. Are you seeing that? Are we together? So what you are left with there, you start. Here you have negative 1 over negative 3 is the same as negative 1 over 3, isn't it? So if you factorize out that negative 1 over 3, what do you remain with this side? See exponential negative 3t, which will be, you substitute the upper limit. If you put infinity there, so you get negative infinity. Exponential negative for big number, which will be what? Then minus, if you put 0 there, so you get exponential 0. Anything raised to power 0 is? Are you seeing that? So 0 minus 1 is what? It's negative 1. So negative 1 times negative a third is 1 over 3. So what is 1 over 3? 0 point? 0.3? 0.33? 0.33 recurring, isn't it? So are you seeing you found the mean to be 0.333? Meaning the mean of t must be a value between the range. You can see 0.333 was starting from 0 and ending at infinity. So when you are looking for the mean of values between 0 to infinity, it must be a value between 0 to infinity. Are you seeing that? Are you seeing the idea here? Meaning if you would have found the mean to be negative, meaning that your mean is wrong, you have to go and check back your working, isn't it? Because the mean of t is a value of t between 0 and infinity, isn't it? Are we together? Good. So where you need to pay attention is when you are evaluating the limits, isn't it? When you are evaluating the limits, it's very, very important, okay? Good. Now, when you want the variance, what do? you must get the expected value of t squared, isn't it? You must get the expected value of t squared before you get the variance, isn't it? So can we get the expected value of t squared? So before we get the variance, we must have the expected value of t squared, meaning it is the integral of t squared times f of dt. Then your limits to be given from 0 up to the end, make it from 0 to infinity, isn't it? Are we together? I substitute your f of t, meaning we are integrating from 0 to infinity. F of t is 3 exponential negative 3 t. So 3 exponential negative 3 t times t squared, you get 3 exponential negative 3td. That is integration by parts, isn't it? It's integration by parts, meaning this one is udv, meaning the polynomial there is u, and the whole of the remaining part is dv, isn't it? Are we together? udv. So your u is 3t squared. So if you differentiate u with respect to t, you get 6t. Then you multiply both sides by dt, you get 60 dt, isn't it? Because this is supposed to be du over dt to give you 60. So if you multiply both sides by dt, you get du is 60 dt. See, there are steps you can now make, isn't it? Are we together? Then the other side, what is your dv? Your dv is exponential negative 3td. So there. So for you to get v from dv, meaning you introduce integral, is what will get rid of this total derivative, isn't it? So if we introduce integral on both sides, integral goes with that d, we remain with b, isn't it? So for us to get b, it means we integrate exponential negative 3t, isn't it? I am integrating exponential negative 3t. The derivative within a function must be a constant. Is when you apply the rule, because that was coming from algebraic substitution, isn't it? So negative 3t, if you differentiate, that is the inner function, you get negative 3, meaning it is working, isn't it? So you are going to get exponential negative 3t the way it is, then you divide by that constant of the inner function, which is negative 3, because we confirm that it is the derivative. That constant must be the derivative of the inner function, isn't it? It's when the algebraic substitution 1. Okay? Good. So we found everything. So what do we know? We know that the integral of udv is uv minus the integral of vdu, isn't it? So udv is uv minus, then you interchange. It is now vdu. If you interchange, you get vd. Is that okay? So start substituting. So what is your udv? Your udv is the problem there. 3t squared exponential negative 3 t dt. That was the udv, isn't it? So b equals to what? uv. So multiply u times v, u times b. 3t squared times, you see 3 will go with 3, will remain with negative. So it is negative t squared exponential. No, there's no integral, it is u times b, isn't it? This times this, isn't it? You get negative t squared exponential negative 3t. Are you seeing that? Are we together, ladies and gentlemen? Eh? Yes, this lady is with us. So it is minus integral of vdu, isn't it? So what is v times du? V is this, send it up. Then du is this, isn't it? So 60 dt times this, 3 goes goes here, you remain with the 2t, isn't it? Then times negative 2 is negative 2t exponential negative 3td dt. Ladies and gentlemen, now look at here. Here is now where I want you to pay attention. At this point, you are done. Don't do any more thing. Now see what is happening. When you are looking for the mean you found, when you are looking for the expected value of t squared, what did you find? You find that the expected value of t squared, you were integrating tf of t, meaning it was t. You were integrating tf of t when you are getting to the expected value of t, I mean, isn't it? The mean, isn't it? What did he integrate? So you integrated t times f of t, which was 3t exponential negative 3t dt. And if you put the limit from 0 to infinity, this was the mean, isn't it? And you found the answer to be what? A third, which was 0.333, isn't it? And that is exactly what is here. Meaning if you remove this negative 2 outside, negative into negative will be, you have positive 2. So what do you see? For you to get 3t exponential negative 3t dt, which the answer was a third, isn't it? Remember this limit, if you put the limit from 0 to infinity, meaning the limit here you're going to put from 0 to infinity, from 0 to infinity, isn't it? Look at the way to do these things. You don't do it fast here. Here you are already done, okay? So for you to get 3t exponential negative 3t dt, meaning you multiply by 3 and you divide by. So for you to remain with 3t inside, so you get this a third outside. See this 3 in the denominator here comes here, it is overlaps. Are we together? And the whole of this answer from 0 to infinity of 3t exponential negative 3t dt, the whole of this, you've already found it to be what? Are you seeing what I mean? Are we together? And the whole of this first integral, you found it to be what? 0. Because when you substitute infinity in exponential here, you are going to get exponential negative over a very big number. And that goes to 0. 0 times anything will be 0 for the upper limit, isn't it? And when you substitute 0, where t is, meaning this t squared, 0 squared will take everything to 0. So it means it will be 0 minus 0, meaning this one part is 0. Are you seeing how to do this thing? Are we together? Meaning this thing is very simple when you are concentrating on what you are doing. Once you got the mean, then doing the second part will be very simple, isn't it? Are we together? So here you found the 0, and this, what is the whole of this integral was the mean. So what do you get here? The answer here will be what? 2 over 3 times what? Times a third. Because here we have plus 2 over 3 outside. Then the integral from 0 to infinity of 3t exponential negative 3t dt, we've already found it, was the mean. Are we together, Nani? Good. So what do you get to be that? 2 over 9. That is the simplest way to go about it, okay? Don't waste time integrating this thing again, because you've already done it when you are looking for the mean. You just manipulate it, isn't it? Are we together? Very good. So we found the expected value of t squared. So can we now get the variance? The variance is, so the variance of t is what? It is that expected value of t squared minus the mean squared, isn't it? Minus the mean, and the mean was the expected value. So it is that mean squared. Are we together? So the expected value of t squared you found is 2 over 9, isn't it? Then it is minus the mean squared. 1 over 3 squared. What do you get? The variance is 1 over 9, which is 0. So this is 1 over 9. 1 squared is 1, 3 squared is 9, isn't it? Lots of it is severe. So 2 over 9 minus 1 over 9, that is 1 over 9. 1 over 9 is 0 0.11. And you have found the variance. So if in case you were looking for the standard deviation, you simply look for the square root of that, isn't it? Are we together? So my friends, we have made a very important concept here. When you are dealing with integration by parts, it will be very easier. You will not do much work in the second part, okay? Good. So that is the variance, 0.1111. Having found the variance, they want what? The median. So how do we get the median? How do we get the median? The halfway, isn't it? Meaning if we integrate up to the median value, we are supposed to get a half, isn't it? Are we together? So the median is what? It is the probability t was starting from 0, meaning t between 0 to the median value will be integrating from 0 to median, isn't it? From 0 to median of f of t dt. And we are supposed to get what? A half. Because the median is a half of the range of a probability measure, isn't it? Are we together? This one, the lower limit is starting from 0, then we are now reaching the median value. We are supposed to get a half. When you do that integration, so that is what? From 0 to infinity, 0 to median, if median is denoted by m, your m from t is what? 3 exponential negative 3t dt. And that should be equals to what? A half. Serious. So start. Remember, 3 is a constant. You can factorize a constant outside, isn't it? So that when you are integrating an exponential function, you must check first of all if the derivative of that exponential function is a constant, isn't it? The derivative of the inner function. So the inner function A is negative 3t. If you differentiate it, you get that negative 3, isn't it? So it means algebraic substitution is working. So what is the answer? We have 3. If you integrate exponential negative 3t, it remains the way it is, then you divide by that constant of inner function, that negative 3, which was the derivative of the inner function, isn't it? Are we together? Then you put your limits from 0 to m, isn't it? From 0 to m is equals to a half. Now here 3 goes with 3, you remain with negative 1. So negative can be factorized outside. Then inside we have negative exponential negative 3, isn't it? Then 0 to m is equals to a half. So we have negative into start substituting. When you put m upper limit where t is, we get exponential negative 3m. If you put m where t is, isn't it? So we'll get exponential negative 3m. See that one, we've substituted the upper limit. Then it is minus lower limit. Lower limit, when you put 0 where t is, isn't it? We'll get the whole of this will go to 0. So exponential raised to power 0 is what? Is 1. Is equals to a half, isn't it? So we can multiply both sides by negative to get rid of this negative after here. Serious? So if you multiply both sides by negative, that one will go to negative a half, isn't it? This is when we now open the bracket. The negative is no longer there, isn't it? Are we together? So you can just open the bracket. There's now nothing outside. Negative 1 going on the other side of the equation. You will remain here with the negative exponential negative 3m. So negative 1 becomes positive 1, isn't it? 1 plus negative a half. It is a half. Are we together? So we have exponential. We have exponential negative 3m is equals to a half. What do? Yes, you introduce ln on both sides because that is the inverse of exponential function, isn't it? So if you introduce ln on both sides, negative 3 becomes it becomes the coefficient. See, the power of a log becomes the coefficient because ln is log to base e, isn't it? Are we together? So negative 3m becomes the coefficient. So there will remain negative 3m because ln of e is 1, isn't it? Are we together? Then on the other side, what is ln of a half? Ln of a half is like 0 minus ln of 2. Because a half means if you take the log inside, division will change to subtraction. So it is ln of 1 minus ln of 2. See, that is negative ln of 2, which is negative 0.6931. So if you look at ln of a half in the calculator, you get negative 0.69331. So what is m? You divide both sides by its coefficient, which is negative 3. So you get m, which is the median, to be what? 0.2331. That is the median value. Are we together? So the median we found is 0.231. You just follow the concept and you see everything is flowing, isn't it? Are we together? The next one, the interquartile. The interquartile range, isn't it? So we know the interquartile range is the upper quartile minus the lower quartile. Then the same interquartile range, we divide the interquartile range by 2, isn't it? Which is the quartile division, isn't it? But here they just want the interquartile range. So you have to get the upper quartile and you must also get the lower quartile. So there. Good. So let us start with the upper quartile or the lower quartile, whichever, it doesn't matter. So the same procedure applies. So It means when you look for the upper quartile, where there is a half for upper quartile is 3/4, isn't it? When you look for the lower quartile, where there's a half for lower quartile is a quarter. Isn't it? Good. Let us do that. So for the lower quartile, Q1, it means we are integrating from the start, from 0 to lower quartile value, isn't it? Are we together? Of f of t dt. And f of t is what? 3 exponential negative 3 dt. And we are supposed to get what? A quarter for lower quartile. If lower quartile is Q1, isn't it? Are we together? You are integrating from the lower limit, which is 0, up to the lower quartile value of f of t. And your f of t is 3 exponential negative 3t, isn't it? With respect to t. And you're supposed to get a quarter. So take the constant outside. So we have 3, then from 0 to lower quartile of exponential negative 3t dt is equals to a quarter. So if you integrate that, what do you get? We have 3 into. You must check if the derivative within a function is a constant, isn't it? If you differentiate negative 3t, you get negative 3, meaning algebraic substitution is working, isn't it? So integrating exponential negative 3t, it remains the way it is, then you divide by that constant of inner function, isn't it? Are we together? Then you put the limits are from 0 to lower quartile, and it is equal to what? A quarter. So you can see 3 goes with the 3, isn't it? 3 goes with 3, so here we remain with what? So by now you know some steps. Upper limit, negative you factorize outside, isn't it? So we have negative into exponential negative 3t from 0 to q1 is equals to a quarter. If you multiply both sides by this negative, it will go on the other side, so the negative is no longer there, isn't it? Are we together? So substitute the upper limit. Where there is t, if you put q1, what do you get? Exponential negative 3q1, isn't it? Then it is minus lower limit. Lower limit, where there is t, you put 0. 0 will take everything into 0. So exponential raised to power 0 is what? Is 1. Anything raised to power 0 is 1. To be equals to negative a quarter. So negative 1 going the other side, it becomes positive 1, isn't it? So we have exponential negative 3q1 is equals to 3 over, because we have negative a quarter plus 1, isn't it? So from there, you introduce ln. So you introduce ln on both sides, ln. Then the power becomes the coefficient, isn't it? So you remain with negative 3q1 to be equals to ln of 3 over 4. Just get the value on the spot. The power becomes ln of is 1. So we remain with negative 3q1, isn't it? Then what is ln of 3 over 4? Negative 2, negative 0.2. Negative 0.287. Negative 0.287. So for you to get Q1, you divide both sides by its coefficient negative 3, isn't it? Are we together? So what is Q1? 0.096, isn't it? Are we together? So that is Q1, isn't it? Now getting Q2 is very simple. You don't repeat the same thing. That is a waste of time, okay? You don't repeat the same thing. So Q2 you simply know is what? You will have here, you remain with negative 3Q2, isn't it? You remain with negative 3Q2 to be equals to ln of 1 over 4. Remember, when you're looking for Q2, it is going to be 3/4. Here it's going to be 3 over 4. So it is going to be negative 3 over 4 plus 1. See, that is a quarter. Isn't it? Meaning you are just going to get ln of a quarter. You don't waste time doing it, isn't it? Are we together? So what is ln of a quarter? Negative 1.38 6, 3. So you know if you are going to be confused, just do it, okay? If you are going to be confused, just because when I'm talking about Q2 here now, if you put Q2, this one goes to 3 over 4, isn't it? This one, if you put Q2, it goes to 3 over 4. If you put Q2 there, then we have 3 over 4, meaning here 3 over 4 all the way. So Q2, so it means -1 plus, -1 plus, -1 way there becomes +1, isn't it? +1 plus -3 over 4 becomes 1 over 4. So your line of 1 over 4 you get to be negative. Then -3, this is now Q2. Are we together? You just repeating the same thing, but it is now 3 over 4. Then you get the answer to be what? You divide both sides by -3, you get Q2 to be 0.461. 4621, isn't it? So what is now the interquartile range? The upper quartile minus the lower quartile. So it is 0.4621 minus 0.096. And you get the answer to be
0.3662.
0.3662. So that is how to get the interquartile range. It is the upper quartile minus the lower quartile.